Okay, number 8, just like we said before, we don't have negative, 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 so we can't use our rule that we just learned. So I'm just going to look at them 2 at a time. So I have a -4 and a +6. So 4 times 6 is 24 different signs, so my answer is negative. And I'm going to bring down that -2. 24 times 2 is 48. I have the same sign, so my answer is positive. All right. Now look at number 9. Number 9 is tricky. Because there's a 0 in there, anything times 0 is 0. I shouldn't have to do any kind of work. But if they would have made something that looked like this, and I've seen it happen before. And just have some crazy stuff. It doesn't matter how many numbers in front or how many numbers behind it. If they're all being multiplied by 0, your answer is going to be 0. So always make sure you don't have a 0 stuck in a bunch of different numbers, so you don't have to do more work than you need to. All right, number 10 and number 11. They look very similar. One has parentheses around the negative and one does not. These are totally different ideas. So if I have a -6 squared, remember for exponents, that means this number times itself 2 times. So I have -6 times -6. All right, well, -6 times -6, that's going to give me a positive 36. Well, what's the difference between this one? Remember when we did absolute value and we said you have to work the absolute value first when we had that negative, I think it was negative, absolute value of -18. And I said we had to work the absolute value first before we dealt with that negative. So the absolute value of -18 was just positive 18, and then we brought that negative down. This is going to be the same type thing. So let me erase this. So if I have no parentheses around it, that just means that I have 6 squared and my answer will be negative. So that negative just sits out in front while we work our exponent. My exponent is 6 times 6. 6 times itself 2 times. So when I work 6 times 6, I get 36, and that negative just comes down into my answer. So notice that there are different signs. One's negative and one's positive. So parentheses really does make a difference, especially when you're dealing with exponents. All right. Our next section in these notes deal with reciprocals, and that's because we're getting into dividing, and when we divide fractions, we have to talk about reciprocals. So that's why we're introducing it here. Now, the reciprocal just means to flip a fraction, and I want to remind you that when you have a whole number, that's the same thing as having a number over 1. So I'm going to write this 11 as over 1. So when I flip this fraction, I'm going to put 1 over 11. Now notice that I did not put an equal sign because they are not equal. They're different numbers. 11 over 1 is not the same thing as 1 over 11. So make sure that you don't put equal sign there. But you don't change the sign, you just flip the fraction. So the reciprocal of 2 over 13 would be 13 over 2. Again, for that number 14, we have -4, and I'm just going to write over 1 so you know how to flip it. And I have 1 over -4. Remember, you don't change the sign is going to stay the same. Number 15, I have -4 over 11, so that's going to be, -4 over 9, so that's going to be 9 over -4. And then this one is tricky. You can think of this as a whole number, like having it over 1. So I'm going to just write over 1. And that's the easiest way to think about it. So if I have this over 1, the reciprocal would be 1 over 0. And this is undefined. So anytime you have 0, the reciprocal of 0 is undefined. Now let's go ahead and get started dividing real numbers. And when we divide real numbers, the rules are the exact same for multiplying real numbers. If you have the same sign, you have a positive answer. Different signs, your answer is negative. So when I divide 21 over 7, or 21 divided by 7 is 3, and my answer is going to be -3. A different sign, so my answer is negative. Here I have 64 divided by 8, and it's a -64 divided by -8. And -64 divided by -8 gives me 8. I have the same sign, so my answer is positive. Now we get into fractions. And when you're dealing with fractions and division, I have a saying that I like to do. It's called keep it, change it, flip it. I'm going to keep that first fraction exactly the same. I'm going to change my division to multiplication. And I'm going to flip or do the reciprocal of the second fraction. So I flipped it instead of 2 over 3. Now it's 3 over 2. Now notice that I don't have division anymore. I'm multiplying fractions. So we're going to do the same thing that we did when we multiplied fractions. I'm going to look at a diagonal to see if I can cross cancel anything. And if I can, I'll reduce in that step. Now the 5 and the 2 is nothing that I can reduce. But the 3 and the 9, 3 will go into both of them. 3 will go into 3 one time. 3 will go to 9 3 times. So when I multiply across, I have 5 times 1 is 5. 3 times 2 is 6. I have different signs, one negative, one positive, so my answer is negative. So again, when you are dividing fractions, you want to keep it, change it, flip it, and then cross cancel if you can. When you cross cancel, or if you can't, then you multiply your numerators to numerators, denominators to the denominators. So let's do it again. Keep it, change it, flip it. Keep that first fraction exactly the same. So negative 2/7 come over. Then I change my division to multiplication. And then I flip the second fraction. Now remember, when you do the reciprocal, the sign does not change. So I keep that negative. And I change it to 5 over 1. Instead of 1 over 5, I have 5 over 1. Now for this one, I can't cross cancel anything. 2 and 1 won't reduce. 5 and 7 won't reduce. So I'm going to go ahead and multiply 2 times 5 and get 10. 7 times 1 and get 7. I have the same sign, so my answer is going to be positive. And I'm going to pick up on the last stuff in the next video.